and that is this force right here is the unbalanced force in box 3. So 39.2 should be my answer there. I do not feel good about that because I did something wrong. It should be 3.92. That makes a lot more sense. 3.92. Yeah, that was right. Okay. Okay. All right. I think that's it. Let me just see if I want to do one of these last couple problems here. I'm going to do this one too because I think this is probably one that some people struggle with because there's some angles involved here. The woman is going up a 13-degree incline with her shopping cart, but her force is horizontal. So there's a component of that force that's up the incline in the direction of the acceleration. So what we're going to have to do is find the component of the force that is in the direction of the acceleration, and then use trig to find out what the horizontal part of that would be. So let's draw a force diagram with what we know. We know the mass of the shopping cart. We know the magnitude of the, or we're trying to find the magnitude of the horizontal force to accelerate it up this incline at that rate. So the acceleration is 1.50 meters per second. And the mass of this thing is 7.8 kilograms. And so we need to find the unbalanced force that causes that. So what we'll need to do is we'll need to draw a little force diagram. And because she's on an incline, we have to follow our rules for drawing force diagrams, and that is to find components that are parallel and perpendicular to the surface. The surface is at this 13-degree angle, so we've got this. I've exaggerated the angle there just, I guess, for effect. But our normal force always goes up at an angle. So we got the force of the, I'll call it the floor on the cart. This is a force diagram of the cart now. Okay, so we're trying to find an unbalanced force to give the cart that acceleration. I've got the force of the earth on, the cart, right there. And then the woman is applying a horizontal force like this. So here's the woman's push. I'll call it the push on the cart, okay? All right, so we're going to stick with our rule of having only horizontal and, parallel and perpendicular components, okay? So the force of the floor on the cart is already perpendicular. I don't have to do anything with that. However, I do have to find a perpendicular component of gravity. I've got to find a parallel component of gravity like this. I know this is the same as the angle of the incline, that's 13 degrees. The mass of the cart is 7.8 kilograms, so I know this is 78 newtons right here using 10.0. 10.0 might be a problem with mastering physics. I have not typically used 10.0 with this. I usually use 9.81. I'm going to go with 10.0 and see. I'm probably not going to be off by enough to cause my answer to be wrong. So 78 newtons, we'll call it that. And then I know I'm trying to solve for this, but the acceleration is in the plane of the floor at that 13-degree angle. So I'm going to have to find components of this force right here. I really don't care about the vertical component, but I do care about, I'm going to call it force of the push on the cart in the x direction, because the unbalanced force is in the x direction. So these two forces here, actually I'm just going to draw it like this. My floor force is going to be the sum of this one right here and this one right here. So I'm not going to worry about that. I'm balanced up and down. Where I'm not balanced is up and down the plane. So this force right here, I'm going to say my parallel gravitational force down here that I just darkened, I have to find that because my unbalanced force is going to be equal to the force of the push on the cart in the x direction minus the force of the earth on the cart in the x direction. Now I call it x because it's parallel to the surface, and you could also call that the parallel force. It doesn't really have to be in those terms. The force of the earth on the cart in the x direction is going to be 78 times the sine of 13 degrees based on that little right triangle down there. That'll give you this side right here, multiplying the magnitude of the hypotenuse times sine of 13. And the unbalanced force, I actually have enough information based on this to find the unbalanced force, but actually, boy, I should have mentioned I'm not looking for the unbalanced force, I'm looking for the person's force on the cart. That's what we're trying to find. The unbalanced force I can get by multiplying 1.5 times 78. It's going to be 11.7, it looks like. And equals the push on the cart in the x direction minus 78 sine of 13. So that means the x component of the push on the cart is going to be, this is 17.5. So the push on the cart has to overcome that and still have 11.7 newtons left over. So that's going to be 29.2 in the x direction. Now that's the x component. That is not the answer. They asked for what is her push so that it accelerates up the ramp, but her push is at an angle. We just found the x component of her push. We know this is 13 degrees, so we're going to have to divide that x component by the cosine of 13 to get her push force. So 29.2 over cosine of 13 is going to give me how hard she has to push it, which is basically exactly 30 newtons, to get a 29 newton force in the direction of the ramp, up the ramp. Now that 29 newton force, just to kind of summarize what we just learned, that 29 newton force, 17.5 newtons of that 29 newton force goes to overcoming this component of gravity down here. Okay, that's working to push the cart down the ramp. So she's got to exert 17.5 newtons just to overcome that. Then this 11.7 newtons is the unbalanced force on top of the 17.5 that accelerates the 7.8 newton or kilogram cart at 1.5 meters per second. Let me just make sure that I got the right answer. It'd be a real shame if I didn't. Okay. Good. Okay. Well, this is a long video, I know, but I wanted you guys to be able to see how some of these are solved. I don't think I'm going to talk about this one, and I will just mention the method of solving this last one. Let me clear this ink off of here. This last one, in order to find the magnitude of the force that keeps this thing moving at constant velocity, the magic words here are constant velocity. So you know this thing is got a unbalanced force of 0. Whatever forces you have in the x direction are offset by forces in the negative x direction. Whatever forces you have in the positive y direction are offset by other forces in the negative y direction. So you find, very much like we did the very first problem in this problem set, you find the resultant of the two forces you know, and then you find the opposite x and y components in the opposite direction. That is going to give you the magnitude of the third force, and it's going to be acting 180 degrees from the direction of these two forces together. The most common mistake is you put the angle of the sum of those two forces go in, and you're trying to find the third force that opposes the sum of those two. So it's going to be 180 degrees from the the sum of those two forces, okay? So I know I didn't go through that numerically, but at least I hope I gave you an idea of how to solve it. If you didn't understand any of these on Monday, come on in, and after you watch this, come on in later in the week, we can talk about it, okay?